Okay, in this video we are going to graph inverse functions, and we're going to take our graph of y equals 1 over x, and we're going to change the number in the numerator to be numbers such as 6 or 2 or 3, and we're going to see what happens to our 1 over x. First thing is that we're going to make a table of values, and there's a little bit of a trick to this. So if we've got y equals 6 over x, I'm going to use inputs of 1 and 6. 1 and 6. I already know that x can't equal 0. X can never equal 0. So I'm going to have a highlighted axis where x equals 0. And that's called an asymptote. X equals 0. That is a vertical asymptote. So I'm going to be able to put values in from negative infinity to 0, but we can never put a 0 in. And then we're going to be able to put in positive numbers to the right of x equals 0. Again, just cannot put in a 0 for x. So I'm going to put in a negative 6, a negative 1, a positive 1, and a positive 6. And the ones are pretty straightforward. Putting a 1 in for x makes calculation very simple. But the same thing with, whatever that numerator is, that's going to be another input. So 6 over 6, 6 over negative 6. Easy to calculate without a calculator. So when I put a negative 6 in, 6 divided by negative 6 is negative 1. So when I put a negative 6 in, 2, 3, 4, 5, 6, I get a negative 1 out. So I'm going to plot that point. When I put a negative 1 in, 6 divided by negative 1 is negative 6. So negative 1, that would be left 1, and then down 1, 2, 3, 4, 5, 6. And what's happening here is normally we've got a curve that is very close to the origin at the curve. And the larger the numerator is, the further that curve is going to get from the origin. Now I need to finish my table. When I put a 1 in, 6 divided by 1 is positive 6. And when I put a 6 in for x, 6 divided by 6 is positive 1. So write 1 up 1, 2, 3, 4, 5, 6. And then write 6, 1, 2, 3, 4, 5, 6 up 1. And there's our graph. Now, what's happening here is that because I can't put a 0 in for x, and because the numerator is a constant, there's no way that the output is ever going to be 0. There's no way to make this fraction equal to 0. That's called a horizontal asymptote, and that horizontal asymptote is y equals 0. Horizontal asymptote. Is at y equals 0. So it says graph the points, connect them with a smooth curve. We did that. Include the horizontal and vertical asymptotes. So we've got a horizontal asymptote. I'm going to call that HA. And that's at y equals 0. I should have done this color coded. And then a vertical asymptote, I'm going to call that VA. And that's at x equals 0. And then the domain of this function, the domain are all the values that we're allowed to put in. So we're allowed to put in, this is going to go to the left forever. So negative infinity all the way to 0, and then not including 0, but then everything to positive infinity. So basically every number except 0. So two different ways that we can write the domain. It would be negative infinity to 0 with a parenthesis, 0 to infinity. Or you can write this as x such that x is not allowed to be 0. And the range, likewise, when we look at the range, we've got outputs that go all the way down to negative infinity, all the way up to positive infinity. Everything in between except for that output of 0. We will never have an output of 0. We will always be either below the x-axis or above the x-axis. So the range would also be negative infinity to 0, 0 to infinity, or y such that y is not equal to 0. Okay, let's try this next one. We're going to graph y equals 2 over x. So what I want you to do is I want you to press pause, and I want you to see if you can determine the 4 inputs to this table, the 4 values that you would put into this table, and then come back, press play, and see if your numbers are the same as mine. Okay, because this numerator is a 2, I'm going to use -2, -1, 1, and 2. So if you look at the last problem was a 6 in the numerator, and I used -6 and +6 along with the 1s. This time, a 2 is in the numerator, so I'm using -2 and +2 along with the 1s. When I put a -2 in, I'm going to get 2 over -2 is -1. When I put a -1 in, 2 divided by -1 is -2. Then when we put a +1 in, 2 divided by 1 is 2. And when we put a +2 in, 2 divided by 2 is 1. So I'm going to plot both of those points, -2, -1, -1, -2. I'm going to have that curve right there, a little bit closer to the origin. And then I'm going to have 1, 2, and 2, 1. Again, a little closer to the origin. And I've got asymptotes at x equals 0 and y equals 0. So x equals 0 is a vertical asymptote, and y equals 0 is a horizontal asymptote. The domain is -infinity to 0, 0 to infinity, and the range is -infinity to 0 and 0 to infinity. That's because x will never be 0 and y will never be 0. Okay, in the next video, we're going to transform our graphs. So we'll come back using this example right here. We will transform those graphs, doing left and right shifts and up and down shifts.